Alright, now we are going to take a look at the dihybrid practice problems from the notes. Alright, so the first thing we got to look at is what are the potential alleles here. So we have hitchhiker's thumb, which is going to be capital H, and that will mean that hitchhiker's thumb is present. Little h means that you have a straight thumb. Big R means that you're able to roll your tongue, and then little r is unable to roll your tongue. Alright, so we now know that my mother is heterozygous for tongue rolling, so she is big R, little r, and heterozygous for hitchhiker's thumb, so big H, little h. My father is also going to be heterozygous for tongue rolling, so big R, little r, and heterozygous for hitchhiker's thumb, so big H, little h. Okay, so now let's put those together for each of them so that we can begin foiling. So you have big R, little r, and big H, little h, times big R, big H, little h. Okay, now we are going to FOIL for the mother. So big R to big H, big R to little h. We'll go ahead down here and write for the mother will be big R, big H, big R, little h. Then we will go again. And we are going to do the second trait for the mother, so little r, big H, and little r, little h. Okay, and because the father is also heterozygous, we know that we're going to get the exact same traits for him. So we can just go ahead and show you that. So big R, big H, big R, little h, little r, big H, little r, little h. So the father is going to be big R, big H, big R, little h, little r, big H, and little r, little h as well. Okay, so now we're going to plug the parents in. So we'll put the mom on the top, big R, big H, big R, little h, little r, big H, and little r, little h. Put the father in on the side, big R, big H, big R, little h, little r, little h, and little r, little h, little r, big H for the second to last one, and then little r, little h for the last one. Okay, now when we cross these individuals, we're going to get big R, big H, big H. So this is going to be a lot like that example that we did in the notes of the big A, big B, that was with both parents being heterozygous. Okay, so let's just finish this out. So big R, big H, little h, big R, big H, big H, big R, big H, little h. So big R, big H, little h, big R, little h, little h. Okay, so this is going to be one that I want to highlight really quick, because this is the first one where we don't have a dominant allele at both parts. Okay, and then we're going to go big R, big H, little h, big R, little h, little h. Again, this is another one that doesn't have a dominant allele at the H position. We have big R, big H, big H. We have big R, big H, little h, little r, big H, big H. this is going to be the first time that we have a little r for both of the alleles at the rolling tongue trait. Next one is going to be little r, big H, little h again. So this is also another one that is going to be little r, big H, little h. Okay, and then we have big R, big H, little h. We have big R, little h, little h. So this will be the final one where we have the little h in there. And then we have little r, big H, little h. And that will be the final spot where we have a little r, two little r's present. And then finally, we have little r, little h, little h. And this is going to be the only, this is going to be the only spot where we have a recessive. Okay, so if we look at the genotypic ratio, actually let's take a look at the phenotypic ratio first. So remember when I said we have two parents that are both heterozygous? What are we going to get for the phenotypic ratio every single time? Go ahead and pause and think to yourself for a second. All right, hopefully you guys were able to come to the conclusion that it's a 9 to 3 to 3 to 1 ratio for the phenotypic ratio every time we have two heterozygotes. And we proved that when we did the cross and highlighted all of these different, we highlighted the H's in yellow, and then we highlighted the R's in pink, and then finally when we had the recessive in orange. And then all the ones that are not highlighted have two dominant alleles present, or have at least one dominant allele present for each of the traits, each of the two traits. Okay, the genotypic ratio is where it gets a little bit harder. So what we want to do here is we gotta find all of the ones that look exactly the same. So we have a big R, and a big H, and a big H. Does that occur anywhere else? So no, 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 no. Okay, so we have 1 out of 16 that are going to be big R, big H, big H. Okay, next. So we have big R, big H, little h. So let's take a look here and see how many of those we have. So we have 1, big R, big H, little h, 2. So look for any more big R's. Nope, doesn't look like we have any more big R's. So I have 2 out of 16 that are big R, big H, little h. Then we'll look for the next one. So big R, big H, big H. So big R, big H. Okay, so here we have another one of those. Big H. We do not have any more, so again we'll have 2 out of 16 that are big R, big H, big H. we'll look for big R, big H, little h. So we have one here, we have one here, we have one here, and we have one here. And then are any of these other ones? Does not look like it. Okay, so we have 4 out of 16 that are going to be big R, big H, little h. Okay, now we're going to go with this one here, underlined in yellow. So big R, little h, little h. And that is the only one. So 1 out of 16. Big R, little h, little h. Big R, little h, little h. See 2 of those. So there'll be 2 out of 16 that are going to be big R, little h, little h. We'll have 1 that is little r, big H, big H. So 1 out of 16. Running out of colors here. Yeah, that doesn't work. Okay. So we'll have big R, little r, big H, little h. Big R, little r, big H, big H. I'm just going to have to switch to this to write it up here so you guys can actually see it. So it'll be 2 out of 16 that are little r, big H, little h. And then finally, we have our final one, which is going to be, I'll write it down here, little r. So 1 out of 16, little r, little h, little h. So we can add those all up. So 1 plus 2 is 3, plus 2 is 5, plus 4 is 9, plus 1 is 10, plus 2 is 12, plus 1 is 13, plus 2 is 15, plus 1 is 16. So we got all of them there. And this is why the dihybrid practice can be a little bit rough, dihybrid crosses, because when you do the full cross like this with the 2 heterozygous parents, you end up with, let's count how many we've got here. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9 different genotypes that show up. So I hope that you enjoyed learning about these crosses here, and I hope it didn't scare you off too much. All right, you guys have a great rest of your day. Thanks for watching.